So in chapter 5 of 606, I will going to show you the technique to convert the real lattice, the cubic, the real lattice to the reciprocal cubic lattice. And then why do we need to use the reciprocal lattice? Because reciprocal lattice is the only way to interpret the diffraction pattern. And why in diffraction pattern important? I will discuss in chapter 5 that this diffraction pattern is actually the only way to investigate the structure of the crystal. I mean, in the Armstrong side. Okay, this is still the only way to interpret. At the same time, the reciprocal lattice, when you draw the Wigner-Zeit cell, you use these two procedures, step 1 and step 2, and then draw on the reciprocal lattice, then you will get the Brillouin zone instead of the Wigner-Zeit cell. If you draw on the real lattice, then you get the Wigner-Zeit cell. If you draw on the reciprocal lattice, then you get the Brillouin zone. Then this Brillouin zone is very important in the energy band structure. And I believe you have heard about this energy band structure, right? That we have like direct band gap, indirect band gap, we have the conduction band, valence band, and so forth and so on. Okay, so this Wigner-Zeit cell concept will also be used in the later chapter. I think chapter 6 or chapter 7, I can't remember. But during that time, we're going to draw the Brillouin zone first, second, third Brillouin zone in the reciprocal lattice. So in this chapter, I will only introduce you the very basics one to draw the Wigner-Zeit cell on the real lattice. So this is, let's say this is the Wigner-Zeit, this is the lattice. So the first step, what to do? Join all the, okay, let's say you need to pick the center one. Okay, let's say I pick this one. So now I need to join a lattice point to its neighbor using straight line. So this one I need to join to all the neighbor. I join to neighbor, I join to neighbor, I join to neighbor, I join to neighbor, neighbor, neighbor. Okay, first step. Then second step, at the middle point and normal to this line, draw a new line in 2D. But of course in 3D that is plane. That means, okay, between these two lattice point in the middle, so this is the middle point, right? So you draw one line perpendicular to the previous line. Okay, then between these two lattice point, we're at the middle. I think this is the middle. So at the middle, you draw one perpendicular point. Same, these two, this is a middle perpendicular point. These two middle perpendicular, middle, then you draw it. So now you can see that we have one enclosed area. And this area, we call this Wigner-Zeit primitive cell. Okay, so this is a Wigner-Zeit primitive cell. So if you use the same way to draw on the reciprocal lattice, then you will get the Brillouin zone. And you draw it further, you will get the second Brillouin zone, third Brillouin zone, and so forth and so on. Okay, so since it is a Wigner-Zeit primitive cell, primitive cell means that it only have one lattice point. How do I know that it only have one lattice point? So you can see that this is half, this is the other half, and then the contribution of this one only have one lattice point. Then this is the next one, this is the next one, this is the next one. Right? So it only have one lattice point. So I give you a short quiz. I want you to draw the Wigner-Zeit cell on this lattice. So it should look like this, okay, the square. Alright, so this is a tutorial. I want you to draw the Bravais lattice for the following arrangement of the atom, and molecule. What's the Bravais lattice? So this is the answer. Alright, so that's all for chapter 1. So I'll proceed to chapter 2 later. And chapter 2 is about the symmetry. Okay.